a little bit for this next section of your notes. And we're going to look at something called Avogadro's principle. And Avogadro was the guy that came up with Avogadro's number, that any sample that contains 1 mole has 6.02 times 10 to the 23rd particles present in that sample. So in Avogadro's principle, he actually discovered this theory by looking at gases first. And he realized if you have 1 mole of a gas, 6.02 times 10 to the 23rd particles, they always take up the same amount of space. So no matter what, as long as you are at the same temperature and the same pressure, typically STP, standard temperature and pressure, your gases are going to contain equal amounts of particles. So equal volumes, same amount of particles. So in the little picture that I have here, I have 2 grams of hydrogen. I have 32 grams of oxygen. So this is 1 mole of hydrogen because of the mass. This is 1 mole of oxygen. Now when these two things combine together to make your water, H2O, you're going to make 1 mole of water molecules. With that 1 mole of water molecules, it has a mass of 18 grams. So no matter what, you have 6.02 times 10 to the 23rd particles in that sample. Whenever you go through, I'm sorry, you're not making that. This is a totally different picture than what I thought it was. Sorry, we're getting into stoic, and there's a similar picture in the stoic unit. And I was thinking it was that one. I apologize. So in this case, it is showing you have 3 different gases. They're not reacting together. They're just 3 different samples of gases. In each of the different samples of gases, each one of them is 1 mole of that gas. They have different masses, but they contain the same amount of particles, and they're going to take up the same amount of space. Now, the amount of space that they actually take up for 1 mole of any of these different things, the video is, or the PowerPoint is not moving forward, and I think I went forward twice. Nope. Okay. Is something called molar volume. The molar volume of a gas at STP is consistent all the time. Remember, STP is standard temperature and pressure. Standard temperature is 0 degrees Celsius. Standard pressure is 1 atm. So molar volume of any gas at STP is 22.4 liters. So in this beach ball, it's approximately 22.4 liters. So in this amount of space, I would have 1 mole of the gas at STP. So the molar volume is 22.4 liters. So what that does for us is we have another standardized value that 1 mole of a gas contains 6.02 times 10 to the 23rd particles. 1 mole is equal to the mass in grams from the periodic table, that molar mass. And then finally, 1 mole of any gas at STP is going to take up 22.4 liters. So now we have 3 conversion factors when it comes to the mole conversions. You can have grams, you can have moles, now you can have liters. And all of those you can take to particles or the reverse from that. So we have another conversion factor. With our second conversion, or I guess third conversion factor that we have here, we can go from moles to particles from the previous unit. We can go from moles to mass from the previous unit when we talked about the mole. Now we can go from moles to liters. Or you can do a multi-step process where maybe you can go from liters to mass by passing through moles first. Or maybe you can go from liters to particles by passing through moles first. So no matter what, everything's going to take us to the mole, and then we can kind of branch out from there. So with our new conversion factor, we're going to do some math problems where they're just going to be simple conversions today like we did in the mole unit. And then we're going to add on to that in tomorrow's video with stoichiometry. So yes, stoichiometry comes back. I told you that it would when we were going through the stoic unit. So surprise, it's back. So this is the foldable that we made in the mole unit. And when we made this, we went from particles to moles, or we went from moles to mass. And we left this top box up here blank, and I said that we would come back to it. The top box is for the word volume. We measure volume in liters. I'm just going to put a capital L for my liters, for my unit that we use for volume. And the conversion factor that we're going to use here is 1 mole is equal to 22.4 liters at STP. Now, for this class, to simplify everything, we're going to assume that things take place at STP if there's no temperatures or pressures given. If there's a different temperature or pressure given that is not STP, you have to use PivNert. But in this case, like with this problem, it just says a canister with a volume of 694 liters contains how many moles of oxygen gas. It makes no mention of STP. We just, for the simplicity of this class, assume that we're going to take place at STP. So we have our conversion factors. 1 mole is equal to 22.4 liters. 1 mole is equal to Avogadro's number, and that's particles. And then 1 mole is equal to the molar mass in grams from the periodic table. So these are the 3 conversion factors that you're going to use on any of these problems. This says that we have liters, and we want to know how many moles. So I'm going from liters to moles. With my 1-step conversion, I only need this 1 conversion factor. To look at the foldable, I have liters, I want moles, I'm only going over 1 line. This is a 1-step problem. You'll never have one more than 2 steps on these. So we're going to start with the number that's given in our question, 694 liters. To get rid of liters, liters has to go in the bottom to cancel. 22.4 liters is equal to 1 mole. To get my sig figs on this problem, I have 3 sig figs here, so I need 3 sig figs in my answer. This is the measurement. That's what's going to drive my sig figs. So I have 694 divided by 22.4. To get my 3 sig figs that I need, the 8 makes the 9 go up, so that's going to go to 31.0 moles. So I showed my work. I have the correct answer. I have the correct unit, and then I have the correct amount of sig figs. So I hope that that one was okay. Like I said, those are the most simplified version of these. This one, it says a chemical reaction produces 1.88 times 10 to the 26 molecules of carbon monoxide gas. What volume, so how many liters, will that gas occupy at STP? So I have molecules, I want liters. If I look at this one, I have molecules, that's a type of particle. I want liters. So I'm going to go from particles to moles, moles to liters. So I'm going to use Avogadro's number and then my 22.4. So just to get my conversion factors here, I'm going to use moles, to liters, moles to particles. I don't need the molar mass at all in this one because it doesn't mention mass. Start with the number that's given in the question, 1.88 times 10 to the 26th molecules. Remember to shorten the word molecule, it's M-O-L-E-C. To get rid of molecules, molecules has to go in the bottom to cancel. 6.02 times 10 to the 23rd molecules for any 1 mole. Next step, I need to get rid of moles and go to liters. 1 mole is equal to 22.4 liters. Moles cancels, molecules cancel, so now I'm just going to do my work in my calculator. So when I have my scientific notation, the 1.88, remember we have to use this EE button right here. So to get to that EE button, I'm going to push second E, and then it's just a 2,6. Times 1 times 22.4. Divided by Avogadro's number, 6.02 second E, 23. I have 3 sig figs in my initial answer, so I need to put my answer in 3 sig figs right here. The 5 makes the 699 go up to 7,000. That's 1 sig fig. If I put a decimal here, that's 4 sig figs. So I'm going to have to put this one into scientific notation in order to get the correct number of sig figs. So I'm going to have 7.00 times 10 to the third, because it's 1, 2, 3 times I move my decimal, and that's liters for an answer. And finally, the last example, it says a container contains 101 liters of argon gas at STP. How many grams of argon is this equal to? So on this question, I have liters. I want grams. So I'm going to have to go from liters to moles by using 22.4 first. Moles to grams by using the molar mass. So I'm going to have to look up argon on the periodic table and find that mass. Start with the number that's given in the question. To get rid of liters, liters has to go in the bottom to cancel. It says 22.4 liters is the amount in 1 mole of any gas at STP. So that got rid of liters, went to moles. 1 mole of argon, I have to find the mass on the periodic table. The mass on the periodic table is going to say 39.95 grams. Moles cancels, that leaves me with grams. I have 3 sig figs here, so I'm going to need 3 sig figs in my answer. 101 times 39.95. I'm really struggling today, sorry. Divided by 22.4. To get my 3 sig figs, I have 1, 2, 3. 1 makes the zeros stay the same, so I'm going to have 180 with a decimal place at the end in grams. I hope that that's helpful. If you guys have any questions, be sure to ask, but we're going to take this molar volume conversion. 1 mole is equal to 22.4 liters. And we're going to use that tomorrow in your stoichiometry problems, where instead of starting with grams, maybe you're going to start with liters instead, or maybe you need your answer in liters. So we're going to use this conversion factor tomorrow in a few more of our problems. If you guys have questions, ask. My email is mgable@crosbyisd.org. Otherwise, have a good day.